Okay, we're going to go over going from standard to vertex form without completing the square. So we're looking at quadratics, and this is the standard form of a quadratic, and this is the vertex form of this quadratic. And normally the way we go from standard to vertex is going through a process called completing the square, which can be tedious and sometimes hard to remember. So there are actually two small formulas that can help us move from one form to the other. And the first thing we're going to notice is that they both have the a value here. Okay, and this a value is really important because essentially it's the same number in both. Now our b and our h, even though they're the same color, are not the same numbers, and same with the c and k, they are not the same numbers. But we can deduce them using little formulas. So what we're going to do is we're going to go through an example of it with each of the formulas, and then after we've done the easy part, if you want to see how these formulas are derived, I'll go through how they got these formulas. Okay, so first we're looking at our standard form of a quadratic. And we need to, in this case, define what our a is. So 5, the coefficient in front of the x squared, is our a. Our negative 10 is the coefficient in front of the x, which is our b. And the constant term is our c, which is really important. To find the x value of the vertex, we plug the standard form a and b into this small formula here. Okay, so we'll do that very quickly here. The x value of the vertex is equal to negative b, so in other words that's negative, and our b value is technically negative 10 divided by the number 2 times our a value, and our a value in this case is a 5. Okay, so if we kind of go across, this becomes negative 1 times negative 10 is positive 10 divided by 10, you get the value of 1. So the x value of the vertex is 1. So we'll kind of write that over here. The x value of our vertex of our quadratic is the value of 1. Okay, and to find the y value of the vertex, we plug in our c. Well, our c is the number 2. Okay, and we subtract our b, which is 10. Okay, and that 10 is going to be squared and divided by 4 times our a value, which is 5. Okay, and simplify that here. That becomes 2. 10 squared is 100. And 4 times 5 gives us the number 20. Okay, we'll get 2 subtracted by 10. 100 divided by 20, that goes in 5 times. So it's 2 subtract 5, which gives us a value of negative 3. So the y value of our vertex is negative 3. Okay, so we've used that formula to very quickly deduce the y value of vertex. If we wanted to put it into vertex form, and remember we said the a is very important here, because the a is the same term, we're going to rewrite this in vertex form. We would get y is equal to, our a value is the exact same as this a value here, so it's 5. We have our bracket, x, and whatever x value is, it's normally called replacing the h, we put the opposite operation of that. So because it's positive 1, we put negative 1 inside the bracket, squared, and then whatever our y value is, that is our k. So we put subtract 3, and this is our h. Okay, so we've built the vertex forms very quickly by using this formula. Okay, next I'm going to go into how we got our two formulas, the x value of the vertex, and then I'll go into how we got the y value of the vertex. And for the first one, you'll have to know the quadratic formula. So we have our quadratic formula here. And what we're going to look at is, in the quadratic formula, essentially we have addition and subtraction of a value. Okay, and this is kind of like one term plus or minus the root of another term. So almost think of these as two separate terms on top of our fraction. Well, I can separate those. If you think of rules, for instance, here's a fraction rule. If I had 5 plus 2 over 3, I could decompose that, so actually make it, I guess, more complex, you could say, is 5 over 3 plus 2 over 3. It's the exact same question. So I'm going to do that here. I'm going to split this, okay? So I'm going to split it right here, so this negative b becomes over 2a, and then the rest of this becomes over 2a. So when we do that, we'll have x is equal to, and I'm going to write it down in black here, negative b over 2a, and then plus or minus the square root, okay, of our b squared minus 4ac divided by 2a. And essentially what this is doing is we're adding and subtracting how far from our axis of symmetry we need to be. Essentially, this formula gives us the axis of symmetry, because if we have a parabola, okay, x-axis is a little off. If we have a parabola here, okay, this negative b over 2a gives us the center, or the axis of symmetry of our parabola, and then this tells us how far left and right we need to go to find the x-intercepts. That's what a quadratic formula does, helps us find our x-intercepts. Well, we can kind of forget this part here. Let's put those. Okay, we can kind of forget that part there, and we're going to have our negative b over 2a. I'm going to write this in permanent there. And that will be our x value of the vertex, or in other words, the axis of symmetry. Okay, so that's how we found the x value of the vertex is equal to negative b over 2 times a. Okay, so we just deduce that. And then for a y value of the vertex, we'll actually have to know how to complete the square. And what I'm going to do is I'm going to complete the square without actually putting in any numbers for this. And I change this to a blue, red somehow. That's fine. Okay. So the very first step when we're completing the square is we actually divide the first two terms by the a value. Okay, we kind of common factor it out. So I'm going to do that with what we have here. So we have y is equal to, the a comes to the outside. Okay, and we'll have x squared, because a, let's divide it by a, right? When we divide these a's, the a's cancel out, plus, and we'll have our b over a times x, and then plus c. Okay. Now, normally in this step here, we take our new b value. Okay, we take this new b value and we apply it to a small formula. The formula is known as b divided by 2, and then we square that. Okay, well, I'm actually going to do this with what we have here. This is our new b. So our new b is actually b divided by a. That's what our new b value is. Okay, so I'm going to show you on the side what that actually becomes, because we're going to add and subtract that value. So on the side, it's like taking b divided by a divided by 2 and then squaring it. Okay, when we do that, a quick way to check this out, essentially this becomes b over 2a. And if you're not sure how I did that, just kind of go through it using your fraction rules of dividing fractions. Okay, but that becomes squared. Okay, so the idea is we're going to multiply b over 2a times b over 2a. Well, b times b will give us b squared, and 2a times 2a will give us 4a squared. Okay, and this is a number we're going to add and subtract inside of these brackets. Okay, so I'm going to rewrite it again. We'll get y is equal to, and I'm going to write everything in black here, x squared plus b over a x, and then we add b squared over 4a squared minus b squared over 4a squared, all inside the brackets, plus our c. Okay, and I'll color code everything at the end again here. The next step will be to take the negative version of what we've just put in there, and the reason we add and subtract that in completing the square is because it's essentially like adding a number and subtracting it, which essentially cancels out. It's like adding a 0 or subtracting a 0. It doesn't actually do anything. But it's important because it helps us build a perfect square trinomial. But we're only focused on the y value. So the next step normally is to take the negative value outside of the brackets. And when you do that, you need to multiply it by the a term. So we got to multiply it by a. So when it comes outside the brackets, we get y is equal to a, x squared plus b over a times x plus b squared over 4a squared. Okay. And when it comes to the outside, it becomes negative. And remember, we multiply by a. So a times b squared over 4a squared plus c. Now this is really important because this is the part that gives you your k value in your vertex form, which is essentially the k value is the y value of the vertex. So we're just going to focus on that part now. Okay, so as we look at that, because I have an a on the top and the bottom, I can cancel out this a, and this one gets reduced by one value because it's a squared. So it then becomes negative b squared over 4a plus c. Okay, and for their formula, they just reverse the order. So the y value of the vertex, or the k of the vertex, okay, becomes this. And they just rearrange it. So we're going to say the k or the y value of the vertex is equal to, and they reverse the order. So it becomes c first, subtract b squared divided by 4a. Okay. And that's how they came up with that formula. And again, that's really important because that's the formula that gives us our y value. This was the formula, that gives us our x value. And here's where we applied it. Okay, so take a look at everything. Perfect.